Namaste, this is SSY. Welcome to MBWI. So this is a very interesting question. In this, what we have, we have multi-stage rocket, and what is the limitation of single-stage rocket? And we have to show that the final velocity of the multi-stage rocket is much greater than the single-stage rocket of the same total weight and fuel supply. ठीक है? So I will solve this problem and I will tell you what is the why do we have single stage rocket, why don't we have single stage rocket and why do we have multi stage rocket. तो पहले बेसिक बता देता हूँ what is a multi stage rocket. Then it is a combination of rocket either joined consecutively, that is series, or one inside the other, or with the rear part of one inside the nozzle of the other. ठीक है. So you can see from the figure that this is a single stage rocket and this is a multi stage rocket. ठीक है, ये एक दो तीन तीन इसके हैं. Now advantages like the limitation क्या है? It carries dead weight of empty fuel tanks throughout the flight, limiting final velocity. Okay, and advantage क्या? Sets empty stage to reduce mass and achieving much greater final velocity for the same in total weight. Now let's do it numerically. Feel it. Okay, let's assume that we have rocket. Okay, we have rocket. ये rocket है अपने पास. And then it's a total mass capital M, and the mass ejecting, that is a delta M, small delta M. And we know that the rocket equation is this. When for the we are considering the simple case for the free space where f external is 0. So after solving we will get the equation this. ठीक है, or I can write simply delta VF, or simply delta VF is equal to, not delta VF, I am just writing delta V is equal to U vector ln mf by m naught. Now if I see, I am telling you, if the expression I change that m naught by mf, and this minus sign is just showing nothing, but the if you have exhaust velocity in this direction, then the rocket velocity will be in this direction. Let's analyze this. If you have this rocket, okay, and exhaust velocity in this u direction, u vector, and then v vector will be in this direction, rocket velocity. So this is the minus sign is showing nothing but just signifying direction. Now let's say, now this equation, now m naught is a rocket mass plus fuel mass, and ff is a mass of rocket at burnout. Okay, now I am giving a problem. कौन सी प्रॉब्लम दे रहा हूँ? I am giving a one problem. उसमें क्या है कि let me erase this. If I say that a rocket जिसका एग्जॉस्ट वेलोसिटी, एक रॉकेट है जिसका एग्जॉस्ट वेलोसिटी और एग्जॉस्ट स्पीड है that u is equal to 2000 मीटर पर सेकेंड. ओके, एंड जो फ्यूल कंटेंट है वो फ्यूल कंटेंट इज 80% ऑफ द रॉकेट मास. और हम कंसीडर कर रहे हैं कि ये टू स्टेज रॉकेट है और दोनों स्टेज में ये फ्यूल कंटेंट सेम रहेगा. आई एम जस्ट कंसीडरिंग इट. और एक बार कंसीडर करूंगा कि एक स्टेज है, तो फर्स्ट स्टेज के लिए फॉर सिंगल लेट इट इज अ सिंगल स्टेज. तो और इनिशियली स्टार्ट हो रही है जीरो वेलोसिटी से, ये भी ध्यान रखना. तो इफ आई कैलकुलेट डेल्टा वी फॉर द सिंगल स्टेज, then it is 2000. I am not considering direction because it is obvious. So ln m naught initial और जो है m naught, and जो m naught है वो है let's say m naught, और जो फाइनल मास बचेगा that is 1/5 m naught. It is 200 ln 5 meter per second. Fine. Now if I consider it is a second stage rocket, okay, if it is a two stage rocket, let's say for multi-stage or two-stage multi-stage. So for the first stage, if I am saying that the thing is transferring, the delta V1 in this case is the same because in the same content structure ln 5. Okay, now this is for the first stage, right? And for this second stage, if I consider, then the fourth second, it is first for the second delta V2 is equal to, again will be same 2000 ln 5. Now the change will be that here initial velocity vi is 0, so final velocity, that is I'm writing v1 is equal to 200 ln 5. Fine. Here the final velocity will be 200 ln 5. plus, not 200, 2000. 2000 ln5 plus 2000 ln5. So it will be 4000. So that's why we have multi-stage rockets. From the numerical, you can see this is the advantage of having multi-stage rocket. So this is the numerical that we have completed.